Hi, we're going to take this metal rack and we're going to be doing a finite element analysis on it. So we're going to be creating a finite element analysis and testing it with some different, well, with a weight and seeing how it performs. So our first step is this. We need to join all these together because right now they're all separate components. You can see if I just turn these off, these are all separate components. Now, if you remember when we made this, we made it just a little bit bigger than it needed to be so that the pieces overlapped. And so that's going to allow us to join all of these together. In fact, you can kind of see this here. If I zoom in and I just look at the length of this line, you can see that it is 600.2 millimeters. So that means that there is a 0.1 millimeter overlap on the right side and on the left side. What I'm going to need to do is I'm going to need to join all these together. To do that, I'm going to use the combine function. So I'm going to click on combine. And really, I want to select everything here. So I'm going to select all of these. So let's start with this one. And then I'm going to select everything. And then I'm going to click OK. This should now be one solid piece. Although I see lots of components here. But you can see, as I'm turning the components off, nothing's disappearing, except for this one right here, which is component 4. So this is now component 4. What I'm going to do is I'm going to start the FEA process. So I'm going to go to design, and I'm going to go to simulation. I'm going to say create a case study, and I want to use this static stress. So I'm going to create my case study here. Now, I need to add some constraints. So I'm going to add structural constraints. And what I need to do is I need to get to the bottom of these, of the metal rack uprights, the parts that would touch the floor. And I need to zoom way in because what I want to do is I want to select this face right here. So you can see that it changes color and becomes gray. So I'm selecting that. And you can see that I've selected one face. I need to do that with all of the feet. So I'm going to go here again and find the bottom of this one, select that face. So you can see I've selected 2 faces. I'll zoom out, come over here, and select this face. I'll zoom out and in and select this face. And then I'll click OK. So I've selected 4 faces. I'm going to click OK. So those are going to be my constraints. I'll go back to the home view. And you can see the little locks on these, which tell me that those are constrained. The next thing I need to do is I need to add a load. So I'm going to use the load, and I'm going to use a structural load. And then I'm going to select the target. And in this case, I'm going to select this part right here. Again, you can see it change color. So I'm going to select that. And the magnitude of the load that I'm going to use, I'm going to use 4,000 newtons, which is roughly equivalent to, it's not quite, but it's roughly equivalent to the force of gravity pulling down on 400 kilograms. So I will click OK. And then I'm going to come up here to pre-check. I can check. It says the study setup has everything that is required. And then I can click on solve. And then solve one case study. Now, it does take a while. You can see that this is doing this here. It's 2%. So it's going to take a little while. But what it will look like when it's done is something like this. Now, once it's done, I can come up here to study and go to results. And I can play with a few different things. Like I can look at the safety factors. And you can see that the safety factors are within range. So most of it is above target. Some of it's in range. There's nothing below target. We can look at stress. I think some of these shear ones are the ones you want to look at. You can see that they're all roughly. This is not going to break. Of course it's going to bend because you can see in the displacement that it's bent quite a bit in the middle. And 400 kilograms is a lot. And this metal rack would not be designed to have 400 kilograms on it. But you can play with these different features on here, these different results that you can look at. You can look at strain, right? You can look at contact force. You can look at all these different things. All right, thank you for watching.